Richland Parish, Louisiana is a rural farming community that has long relied on crops like cotton and soybeans to survive. But right in the middle of these fields sits Project Sucre, the secretive codename for Meta's new Hyperion facility. It's a 4 million square foot data center complex, landing squarely in this rural landscape. This diagram illustrates the sheer scale of power required to run it. A single 5 gigawatt data center demands the same amount of electricity needed to power roughly 4.2 million average residential homes. Silicon Valley gets the cheap land and power it needs to fuel its artificial intelligence ambitions. But for a town looking for a financial lifeline, it's worth asking exactly what they're getting in return. To convince Meta to build such a massive facility here, Louisiana had to open its checkbook. State lawmakers quickly rewrote existing legislation, specifically a law called Act 730. They tailored the text to grant data centers 20 to 30 years of sales and use tax rebates on both construction and computing equipment. Then came the energy approvals. The local utility needed to build entirely new natural gas power plants to supply the site. To get it done quickly, regulators waived standard competitive bidding rules that usually ensure the public gets the best financial deal. Louisiana isn't alone in this approach. Across the country, tech giants are racing to secure land and electricity to train their AI models, while state governments compete against one another by slashing regulations and offering steep subsidies. The core of this agreement relies on a very specific trade. The state sacrifices decades of future tax revenue and standard regulatory oversight, betting that a localized tech boom will eventually pay off. When construction begins, the impact is immediate. Richland Parish has about 20,000 permanent residents. At its peak, this project brings in 5,000 temporary, out-of-state construction workers. That sudden influx of people injects cash directly into the local economy. Convenience stores empty their shelves, local restaurants are packed, and raw land values spike sharply as owners look to cash in. But that same influx creates severe friction. Demand for housing causes local rents to skyrocket, pricing out existing residents. Meanwhile, the massive earth-moving operation blankets nearby neighborhoods in construction dust. The building phase provides a sudden burst of cash, but it brings immediate inflationary pressure and physical disruption to a low-income community. It's easy to think of artificial intelligence as something floating invisibly in the cloud, but training these models is a heavy, physical industrial process. These dense server racks generate massive amounts of thermal energy, requiring industrial-scale fans and cooling systems to keep them from melting down. This chart shows how that cooling translates to water usage. Hyperion is projected to draw up to 1 billion gallons of water every year from the exact same local aquifer that farmers rely on to irrigate their crops. And then there is the electricity required to power the racks themselves. The local utility, Entergy, is constructing 3 new natural gas power plants for the explicit purpose of keeping these specific servers running. Despite those massive physical inputs, the human output is surprisingly small. By the year 2035, Meta is only required to create 500 permanent, full-time jobs at the facility. A modern data center does not operate like a traditional factory that hires thousands of local workers. It acts as a highly automated machine, extracting natural resources and converting them into computing power for a distant corporation. Right now, companies like Meta, Google, and Microsoft are spending billions on infrastructure, locked in an arms race to dominate the AI market. But the hardware driving that race has a very short shelf life. This timeline illustrates how fast AI chips become obsolete. To stay agile, Meta structures its facility leases in short 4-year increments. Notice the discrepancy when we extend the timeline to include the utility infrastructure. The physical natural gas plants are designed to operate for 30 to 40 years, but the tech contracts only lock in revenue for 15 to 20 years. That leaves a massive gap in long-term financial backing. If the economics of AI falter, or if Meta decides to pivot its hardware strategy and walk away early, that timeline mismatch becomes a serious financial liability. If the tech giant leaves when its contract expires, the multi-billion-dollar cost of maintaining and operating those gas plants doesn't just disappear. Even under the current deal, where Meta covers the power plants up front, local ratepayers are already responsible for hundreds of millions of dollars in new transmission lines required to handle the grid strain. We can see the results of this dynamic in other regions. In states with high concentrations of data centers, residential consumers consistently see their utility bills spike as the cost of upgrading the local grid gets passed down to them. To build out the physical infrastructure for artificial intelligence, tech companies are relying on rural communities to supply the land, the local water, the needed electricity, and the tax breaks. Silicon Valley keeps the global profits generated by the technology. But if the economics driving this rapid expansion ever fall apart, the taxpayers and ratepayers of Richland Parish will be the ones left holding the bill for the infrastructure left behind in the bayou.